All right, boys and girls, welcome back to the drive-thru for a very brief confessional brought to you, as always, by the deli. Hungry? Stop by the deli. Enjoy yourself a Thanksgiving feast to be prepared potluck style next week. All right, so this is 6-2. There's only one theorem in this whole section, okay? So if it seems like we're going slow, we are. We're trying to give you guys a chance to work in 3 dimensions and succeed at it and understand it, because eventually, you know, with the ability in today's world to do so much mapping and so much 3-dimensional stuff, this is way more important for you to understand now than it was for me to understand in 1995. Okay? So we really want to make sure that you guys get a chance to really understand and see things in 3 dimensions, because that's obviously, you know, how they work. So that's why we are slowing down. I encourage you to widmapoi as well as you possibly can. Remember that we're going to refer to planes as like flattened parallelograms. Okay, so we've always been looking at it in 2 dimensions. Now you can kind of look at it like it's got some perspective, you know, when things... Okay, that's what I'm trying to explain. Here we go. So, this is the theorem today. If a line is perpendicular to 2 distinct lines that lie in a plane and pass through its foot, then it is perpendicular to the plane. I do not expect you to like or understand that all that well, so let me explain what's going on in all the words. Okay, all right, we have a plane. Okay, now in that plane, we have 2 distinct lines, meaning it's not, one line written 2 different ways. It's 2 distinct lines, okay? Those 2 lines intersect with each other. If I can create a line, okay, this thing right there, that point is the foot. The foot is where a line touches the plane. Okay, so since we're calling this black line a line, I should indicate that it continues to go through that plane. Okay, now what we're saying is that, and this is where I encourage you to work on your little perspective here. I'm no artist by any means, but I've gotten better over the years at drawing these. So there I've indicated that the black line is parallel to the red line. And here, the black line is parallel to the green line. Okay? Sorry, perpendicular to the green line. So if we have those qualities, if we have a line that is perpendicular to 2 distinct lines that lie in a plane, then that black line is perpendicular to the plane. Okay? So, let me explain why it's 2. Draw ourselves another plane. Okay. Here's what I want you to understand. Well, you could draw 2 lines in that plane that are perpendicular to each other. Okay? You would not say that, here I call these the same thing, so let's call that line A and line B. You would not say that line A was perpendicular to the plane just because it was perpendicular to line B. So there you have an example of one line perpendicular to another line, and line A is not perpendicular to the plane. Let's look at another example. Okay, here we have line A again. Now I want you to consider this line here that is traveling at some angle and it's traveling through and coming out the other side. Let's try this again. Okay, let's say we've got a line here. It's coming down, it's intersecting at the foot. Here we have line B. Line B is intersecting there at the foot, and it's continuing to travel on, and it's shooting out at the bottom. Okay? Now, we could have line B be perpendicular to line A and easily not be perpendicular to the plane. Okay? In order to kind of visualize that, I'd like for you to take out 2 writing utensils and place one of them on your desk. Okay? Now, take your other pen or pencil and make it perpendicular to that pen so that it is sticking straight up towards the ceiling. Okay, now rotate that pen or pencil so that it is still perpendicular to the other pen, but it is not perpendicular to the desk. Hopefully you can now see that line A and line B could be perpendicular to each other without line B being perpendicular to the plane. And from there, all you're going to have are some applied questions today, mostly some 3-dimensional proofs. You should do just fine with them. Boom!